Hello, in this video I teach you how to use Tracker to analyze the motion of objects. The Tracker app looks like this, the icon, and you can search from your startup menu, Software Center. You can select this. I already have my Software Center up, and you can search Tracker like so. And you should see an icon pop up from your search result that looks like this. For some reason, Tracker does not work in my Software Center, or I can't find it. So alternatively, you can download Tracker to an external hard drive or a flash drive and run it from the flash drive without downloading it to your computer, which is what I've done. So to do that, I go Google Tracker Physics, and I select the first link that pops up. And so here I'm back to start. And now I go download Tracker 4.11.0 installer for Windows. I select that and I make sure my file destination is my USB drive, or in this case my external hard drive. So I click save. See, I already have mine already saved in my USB. I'm going to click cancel instead. Inside the USB, once I have the installer saved, I can double click the installer. Yes for the user control, which pops up. You won't be able to see that in the video though. So yes in the admin control. And then I run the setup wizard and I save the tracker to my USB. I've already run the setup and installed, so I'm going to abort the installation process and show you where I have this saved inside my USB drive. It's called Tracker, and it is the icon, the application, not the icon. So I can double click and I have Tracker now on my computer without having it downloaded. Again, you can also just download it from the Software Center. Next thing I need to do is go to my startup menu again, and I search something called the snipping tool, and I right click and pin to taskbar. This is going to let me take screenshots of any part of my screen without having to edit or crop down the size if I were to use the print screen button, but we'll see that in a sec. You're going to go to the hub and you're going to download the Tracker Prelab and the ball toss video, both of which I've already downloaded. Go back to Tracker, open my Prelab video, and I can see the first thing asks me to insert a copy of X versus T graph in the space below. So let's go ahead and generate a graph in Tracker. I need to click this manila folder and I go File, Open, and I search for a copy of the balltoss.mov and I open that. Some people had difficulty loading the ball toss video into Tracker. If that's the case, close down your Tracker application, go back to the Software Center, search something called VLC Media Player, download the VLC Media Player from your Software Center, re-download the ball toss video, reopen Tracker, and you should be able to see your movie. Let's begin plotting. This is a video of a ball being tossed into a trash can. So to start, we grab these purple bars right here. These are our coordinate axes. And we grab the middle and we slide it right over to the center of the ball. Make sure it says 0 degrees from the horizontal. Now I click the bars again so they go away. I need to set the scale of distance in this video. This is 62 centimeters long. So I grab this blue bar that has the number 10, I click New, Calibration Stick, and I need to rotate this. As I rotate, I can see the angle is changing. If I start dragging down like this, and I see it's at negative 89, I need to make sure it's positive 90 degrees. I can only flip this by dragging it. So I make sure it's lined up, nice 90 degrees, and I got it. This is a distance of 62 centimeters, not 100 meters. So we convert 62 centimeters to meters, that's 0.62 meters, enter, and we're ready to start tracking the motion of this ball. Next we click Create, Point Mass. and this tab comes up. Make sure I have this selected so I can track the motion of the object. Now I hold down Shift and a little box comes up. I place this box over my object while holding Shift, and I click with my mouse. Hold down Shift and I click with my left mouse button. Holding down Shift, click, Shift, click, Shift, click. The video automatically jumps forward, and I keep doing this for the ball. Shift, click, Shift, click, Shift, click, all the way down, going. As I do this, you'll see a nice line graph is being generated. Shift, click, Shift, click, Shift, click, Shift, click, all the way until the ball is just in the trash can. Now I'm going to analyze this graph that was made. I right click on the graph, analyze, and a new window pops up. Now with this new window, I go to analyze again, I make sure curve fits is selected, and now I have a line graph generated, auto fit is selected, and an equation for this line. So my A value to plug in is right here, and my B value is right here. Let's use our snipping tool to answer the first question in the pre-lab. So my snipping tool, I go to New, and I can drag over this. Let me redo that. Click New again. I want a picture of the graph and the information to generate an equation for this line. This automatically copies to my clipboard, so I can now go into Word, where it says insert a copy of the graph in the space below, and I go Control Paste. And there I have it. I have a graph now. What's the equation for this line? Well, that's easy. I can just plug in this A value for the A and the B value for the B. So the equation for this line is x equals 1.766. I'm going to leave off the E0. That just means times 1. 1.766 times t plus my B value is 8.176, E negative 3. Excellent. For my SL students, can you see if this would have a low or high systematic error? Okay, what does the slope of this line tell you? The slope of a position versus time graph is velocity. Next it says insert a copy of the y versus t graph in the space below. So now we need to go back to Tracker and make a line, a graph of y versus t. So back on the main Tracker screen, I click the label for the y-axis and I change it from x position to y position. And now I have this nice smooth looking parabola. It should be an upside down parabola. If my parabola isn't upside down, if it looks like this, that's because my axes aren't set at an angle from the horizontal of 0 degrees. It's probably negative 180 degrees. Or it's probably 180 degrees, excuse me. So I will need to change this from 180 degrees to 0 degrees. And once I do that, my graph looks normal. So again, once I have this upside down parabola, I right click, analyze again. I should find this window. If it doesn't automatically pop up, just grab it from your taskbar. And I have two graphs. I just need to look at the y versus t graph. So I go to the x versus t column, I right click it, cut the column, and now I just have a graph of my parabola. This is not a line graph, this is a parabola, so I change the fit name to parabola, auto fit select, and there we go. I can make an equation for this graph by plugging in my A, B, and C values given into the formula. I want to make a screenshot of this, so again I go New, I drag down to get my data, and then I can open the Word document again, and I go Control V to paste this into my document. What's the y versus t? Why is the y versus t graph a parabola instead of a line? For this, we will say there is no horizontal acceleration. You may not know why that is, but I assure you it's true, and in the coming days we'll learn more about that. Then you're going to insert a copy of v sub y versus t in the space below. Give me the equation for that line. And what does the slope of a velocity versus time graph tell you? Well, it gives you acceleration. We will submit these documents in class. That's all for now. I hope you found this video helpful and keep studying.